transmission system. Dr. Praveen Kale sir is recognized as a well-known academician, researcher, and administrator in the field of technical education at Savitribai Phule Pune University, Pune, with bachelor's degree from one of the reputed NITs, VNIT Nagpur, and doctorate from Government Engineering College, Ujjain, Indore. He has extended his unstinted services to Pune University for the past 33 years. His key research competence include vehicle dynamics, machine design, fatigue and fracture analysis, noise and vibration, stress analysis, mechanical behavior of materials. He has guided more than 20 postgraduate students and published 25 research articles at national and international journals and conferences. His first book on design engineering is published by publisher Dhanpat Rai and Sons, Delhi. Currently, Sir is working as professor and head in mechanical engineering department, PCET's Pimpri Chinchwad College of Engineering, Pune. So without wasting much time, I hand over session to Dr. Praveen Kale, sir. Sir, you can now share the screen. Hello. Yes. Yes, we can see the screen, sir.
Am I audible?
Yes, sir. Now you are audible, sir.
And
Yes, sir.
presentation is also visible.
Yes, sir. Presentation is visible. Please go to full screen mode. Yes, sir.
1 minute. Why this window is opening here?
We can see your screen, sir.
Now there is a black window in front of me.
Okay.
Yes. Now good evening all. Welcome to this AICT training learning ATAL faculty training program. My now today's topic is innovations in electric vehicle transmission system. Actually, the innovations in electric vehicle transmission system. Transmission system is the heart of the electric vehicle. Even though there are so many vehicles, IC engine based or electrical and other types of vehicles, but transmission, without transmission, it is not possible to start any vehicle. Even in electric vehicle, transmission is important. Transmission system is very important. Now, what are the contents? The contents of this session is an overview of electric vehicle. What are the different types of electric vehicle? What is the market demand? Why demand is increasing? This is what the overall review of the electric vehicle. This is my first point. Then what are the different types of electric vehicles? Then transmission systems. What are the different transmission systems? Because without transmission, what are the different types? Where it is used? For what purpose it is used? So that type of transmission system I will highlight. Then since my focus is on transmission system, and definitely what are the different parts where you can work, where the innovations are developing or innovations are going for researchers or for students, those who are interested in PhD or other publications. So what are the different areas that I will highlight only? In transmission system is a big unit. It consists of different parts. So in that case, what are the different areas where you can do some things different? So still that area is open. So I will highlight only that innovations or areas, that is dual clutch transmission, continuously variable. These are the topics where you can start your research work or you can do your PhD. Then integrated transmission. So these are the 3, 4, 5, 6 different areas where you can work. That is what my intention. And then lastly, I will study one case study. I will present one case study that is related to single speed transmission system. This is what my total overall session. Now, of course, in overview, the demand of electric vehicle is increasing, no doubt. If you see, in electric vehicles are transforming the global automotive industry driven by the technological advancement. Of course, the technological advancement is essential. Environmental concerns are there. Also, the government is supporting, government policies are supporting for the development or growing market. If you see this market, the market is growing exponentially. It's very drastically increasing. Now, in electric vehicle, the exponential growth in last decades, the exponential growth is there, and that is only because of the improved infrastructure and declining the cost of electric vehicle batteries. The battery is the, of course, important component, but because of this cost of electric vehicle or electric vehicle batteries, the cost is slightly declining. At the same time, what is the second part? The projected growth. According to the industry forecast, the global electric vehicle market is expected to grow at least 20 to 30% over the next decades. If you consider the next 10 years, what happened? The demand will increase, or the growth of the electric vehicle will increase by 20 to 30%. This is compound annual growth rate. That what I have collected in the information. Then, of course, the leading market, China, the world largest EV market. Then high adoption rate in Europe. Europe is also giving significant for following the stringent emission regulations, and therefore they are providing, or government is providing subsidies. Because of that, the demand is increasing and rapid growth is there. Okay. Now in United States, California is having the highest rate of adoption. Okay. Now, what are the different factors? Adoption rate, the rising number. The number is also increased. If you see the last decade, the demand was 14%. Now in future or in 25, the demand is expected to 25%. This is what the expectation. It will increase minimum by 25%, and that is only because of the decrease in battery cost. That is only because of the decrease in battery cost. Then policy of the drivers, or policy for drivers, subsidies are given, tax breaks, exemptions from tolls or parking fees, and the regulations, mandatory regulations to phase out the internal combustion engine. Okay. Before 2035, this was what the mandatory regulation by some countries, and therefore the demand is also increasing. Then corporate adoption is also one important parameter. Most of the companies are electrifying their fleets to meet the sustainability goals. This is what also the important parameters, and hence the key factors influencing the growth. Of course, these are the three main parameters. The technology is improved battery technology particularly. Then cost parity, battery prices have dropped significantly. And the third one is environmental consideration, environmental awareness. Okay, air pollution and carbon emission are the main important parameters. The lower the health effects from the air pollution. This is what the main important parameters over this. Then what are the challenges? In challenges, limited charging infrastructure. Still, the infrastructure is very less. The charging stations are very less, and therefore limited infrastructure, limited charging station in developing regions also. Then high initial cost. This is also one of the important parameter. Then raw material sources for batteries. That is also one of the important. These are the challenges in the electric vehicle. Then of course there is a opportunities. The opportunities renewable energy integration with electric vehicle charging network. You can use solar energy. Then high battery cycling and second life application. The battery recycling, you can recycle the battery and you can give the second life for the battery. This is also the challenging or opportunities where you can work. Then innovations in electric vehicle technology. Here it is always open. The technology is always open, which includes the autonomous electric vehicle and solid state batteries. Now the solid state batteries are introducing. The lithium oil ion batteries are replaced by these solid state batteries. Now, before going to this in overview also, what are the different electric vehicles? One is purely electric vehicle, battery electric vehicle, okay, also known as all electric vehicle. It is purely electric vehicle, entirely on battery powered electric drivetrain. Okay, large battery pack plugging into electricity grid is required. Battery pack provides power to one or more electric motors. You can use one motor for front wheel drive or two motors for both front and rear. That depends what you are using. Okay, even four wheel drive also possible. Then main components are, of course, the electric motor is there, which is very important component. Then inverter, AC/DC, battery, control module, because since battery you are using, everything is electronics and it is easily possible. The control units are there, electronics control units are there. Then drivetrain. Okay, the drivetrain is what the main focus area for this particular session. Then working principle that and these are the examples, different examples. Then hybrid electric vehicle. Second is hybrid electric vehicle, in which you can use both the conventional engine, IC engine, and the electric motor. In hybrid electric vehicle, this electric motor is essential and engine. Gasoline or any type of fuel you can use. That is what the hybrid electric vehicle. Engine gets energized from fuel and the motor gets electricity from the batteries. Okay. Then main components of this hybrid electric vehicle is engine, electric motor, battery pack with controllers, inverter, fuel tank is there, and the control module. Control unit module is everywhere. These are the examples of the hybrid electric vehicle. Then plug-in hybrid electric vehicle, now also known as a series hybrid. It is particularly a series hybrid and have both engine and motor. Again, it is, but the most of the motor is plugged. Okay, most of the part it's most of the time vehicle they run by electric motor, and therefore this plug-in hybrid electric vehicle is used. Can choose among the fuels, conventional fuel, petrol, or alternative fuel. Boiled biodiesel is also applicable or used for this plug-in. Now, to explore recent innovations. Now, what are the innovations, or what are the possible innovations, or what are the old innovations? Because innovations is a continuous system. Therefore, highlights on advancement. What are the advancement? What are the development? These are the important parameters. Therefore, highlights the advancement. Then what are the benefits? In the benefits, then what are the challenges? To analyze the challenges, and what are the future trends. Now here in development, what? The highlights advancement. Development means what? Developments in electric transmission system. This is particularly transmission system. To explore the transmission, what are the different types? How can you improve whether the electric motor is required, transmission is required for electric motor, that we have to think. And therefore this advancement in highlights the development in advancement. Then examine benefits. What are the benefits? Of course, the range will increase, range will improve. Then what is the analyzing challenges? What type of parts you have to analyze? If you have to design a gear, or you have to change the any other type of system, so what are the different analyzing parameter that you have to study, and what are the future trend that we have to see one by one. Now, to understand their impact or efficiency, performance, and sustainability, of course, the customer demand is always a very high speed and then comfort and so on, so on. But in case of electric vehicle, the main important parameters is the efficiency. Efficiency should be maximum. The efficiency should be maximum, and the performance of the vehicle, which includes the enhancement in acceleration, improved top speed, then driving dynamics, whether when you are taking cornering of the vehicles or during turning of the vehicle. So what are the different forces acting on the vehicle that you have to study? So this performance of the vehicle, then sustainability, which reduce the carbon footprint, then lightweight and durable designs are also useful. Then support for renewable integration and life cycle benefits. Now, what are the challenges? In challenges, the balancing performance and cost. The main important parameter is what? The cost in advanced transmission design. Okay? Because you have to improve the balancing performance. You have to give the good performance as well as you have to compromise on the cost. Both are challenging. When you have to improve the performance of the vehicle, definitely somewhere you have to compromise. So that cost and performance you have to compromise. Then addressing weight and space. Of course, if you decrease or reduce the weight and space, because you required more battery pack, and therefore what happened? The space is required for battery pack. At the same time, the weight is to be reduced. You have to reduce the weight. So for weight and space constraints are the important parameters or challenging parameters. Then managing heat and durability of high torque application. The heat thermal management is the main important parameter in the design of electric vehicle, because tremendous heat is generated. You have to dissipate the same amount of heat. Therefore, heat management or thermal management is the important parameter. Then what are the different opportunities? In opportunities, development of frictional and solid state systems for higher efficiency and reliability. Of course, the different developments in frictionless component. Now battery is frictionless. Instead of engine, you are using reciprocating engine. So to and fro motion, there is a friction, and now it is replaced by a frictionless and solid state system. So solid state system means what? It's a battery. We consider solid state battery. Okay, where's instead of lithium ion battery, we can use solid state battery. Then integration of smart and AI driven transmission system. The transmission system is now driven by AI, or some integration of smart transmission system is there. So that is also important. Then enhance transmission design for emerging EV market. So these are the opportunities where you can work. Now, what is transmission system? In transmission system is a crucial component of drivetrain. Definitely, it is a crucial component of drivetrain, responsible for transferring power from engine to motor. You have to transmit the power from engine to motor, or electric motor to wheel. So this is what the transmission system. You require the transmission system, which consists of different gears. These are the different parts. Electric motor. The total transmission system consists of the electric motor is one of the parameter now, one of the component of the unit, transmission unit. Then gearbox, differential is required, axle is there, So these are the different components of transmission system. Now, do you really require the transmission system? This is what my question. Is it really required? Because when you see the characteristic core of traditional IC engine transmission, so what happened? The power is required. Of course, this is what the first core is gives us the power versus or speed, and then for this is for IC engine transmission, and the second core gives the electric vehicle transmission. In IC engine transmission, if you see the behavior of the core, or the in case of what we can say that torque, first you take the torque is initially less. When the torque is less or the speed is less, the torque produced is also less. At one particular speed, the torque is maximum, and after that it starts decreasing. So when the torque speed is less, the torque provided is also less, and therefore you have to amplify the torque, because in case of IC engine or in the IC engine vehicle or IC engine transmission, you have to increase the torque, because at low speed, low load, what you required? A speed. You required a torque. More torque is required in case of IC engine transmission initially. And therefore, at the same time, if you see the electric vehicle, this is electric vehicle transmission system. Now, theoretically, we can say that at zero speed, the torque required is maximum. The torque produced by the electric motor is maximum, and it is almost constant. It is constant throughout up to particular speed, that is called as a base speed. That means at low speed, the torque provided by the electric motor is maximum. That means when you have to accelerate the vehicle at low speed, when you are driving in the city, a crowded area, you required a more torque. Your speed is very less. So at less speed, you can easily accelerate the vehicle. Now, therefore, this is the advantage, or this is the basic requirement of the vehicle. Actually, it is a requirement of the vehicle. Therefore, up to this certain range, what happened? The power produced or the torque required, the torque produced by the electric motor is very large. But after some particular speed or the basic speed, it starts decreasing. Now, this is the torque curve. But what about the power? The power is zero. The power is zero when the speed is less. When the speed increases, your power is increasing linearly. And after that, it is stable. That means if the power increases after some particular speed, it is almost same. So this is what the good characteristics for the EV transmission. In case of IC engine, you require the gear, because you require the transmission system to increase or to amplify the torque, to increase the torque at low speed. And therefore, first speed, second speed, different speed ratios are required. A multi-speed gearbox is required, 1 speed, 2, 4 speed, 6 speed, whatever it is, it depends. Okay. So this is what the disadvantage of the IC engine transmission, that transmission system is reduced in case of the electric vehicle. You can reduce it, you cannot omit. Now, this is what basic difference: the power source, internal combustion engine, electric motor, gears, multi-speed gearbox, 5 to 10 speeds typically speed. Then single speed gearbox is sufficient, or in some cases 2-speed gearbox, not multi-speed, it is 2-speed. It is now up to till today only maximum 2-speed can be 2-speed multi-speed gearbox is used in electric vehicle transmission system. Normally in maximum cases it is single speed gearbox. Then torque deliveries requires gears to amplify torque at low RPM. Yes, you have to increase the torque, and therefore this torque delivery is essential. Then in case of electric motor, instant torque, suddenly you can increase the speed of the vehicle. You can accelerate easily, reducing the need of gearbox. Therefore, the gearbox is not needed. Then clutch or torque converter used to disengage the engines because you required some engagement and disengagement. Therefore, you have to use a clutch for idling and gear shifting. But in case of this, not required due to linear power delivery of the electric motor. You have seen. Then shifting mechanism, of course, manual or automatic. Then automatic and seamless in case of electric vehicle. A differential separate components in the drivetrain, then often integrated into a compact e-axle system or the electronic axle system. In electronic axle system, what happened? The total transmission system is it's closed in one casing and that is mounted on the axle. This is called an integrated compact e-axle system. Instead of separate electric motor, drive transmission system, second electric motor or everything, instead of that, or differential and shifting arrangement, shifting gear, everything is now closed in or electronic unit, control unit. All these are closed in one casing and it is mounted on the axle and therefore it is called e-axle system. This then maintenance is regular servicing, clutch repairing. Then maintenance is comparatively less because no moving parts or lesser moving parts. Then energy losses, higher losses due to complex mechanical components, lower efficiency is more. Now these are the functional advantages of EV transmission system. The functional advantages: efficiency, of course, higher efficiency as they eliminates energy losses. Then performance, instant torque from electric motor provides smooth acceleration without the need of gear shifts. Therefore, performance is also important. Then compactness, reduced space and weight compared to bulky transmission system in IC engine vehicle. And durability, less wear and longer components. Now, different types of electric vehicle transmission system, particularly single speed. In single speed, okay, yes, 1 minute. Just 1 minute. Am I audible now? Is it clear now?
Yes, sir. Yes, sir. You're audible.
Now, this is single speed transmission or single speed transmission system in which the most common transmission in electric vehicle, which is commonly used, only one reduction ratio. Normally it is 2, 3, 4, 5, 6 maximum. It's less than 6. Then rely on unique characteristics of electric motor. This is what the key feature of the single unique characteristics of electric motor. Ideal for most driving scenarios due to broad torque range of electric motors. This is very ideal for most driving scenario. Most of the cases, this single speed transmission system is used. And most EVs features is single speed reduction gear, simplify the drivetrain and reducing the maintenance need. Now, what is single speed transmission? In single speed gearbox system that connects electric motor to the drivetrain at constant gear ratio. This is gear ratio, constant gear ratio. And the simplified design with fewer simple design, just you have to follow the gear design procedure only. The simple design, helical gear is used, integrated with motor and differential in most of the EVs. The differential gear is a part of a gearbox. It is inside the gearbox out on the output shaft of the electric vehicle. Then allowing the motor to drive the wheel without the need of shifting multiple gears, okay, between the multiple gears. Now these are the distinct advantages of single transmission system. First one is wide torque band. The wide torque band is the main characteristic of the electric vehicle. We have seen the torque is from 0 to maximum, and it is then almost same. Okay, after that it starts decreasing. Therefore, wide torque band, then electric motors deliver near constant torque from 0 rpm. Then maintain efficiency over a broad speed range. The speed range is also good. Then third one is eliminates the need of multiple gears to optimize power delivery. Then high RPM capability. Electric motors can spin at high speed. If the speed, in sometimes what happens, the speed of the electric motor is very, very high. It is more than 20,000 or sometimes it is 60,000, 80,000. So in that case, the motor starts spinning, and therefore this is what the high RPM capability is required. In that case, multi-speed can be used. Then reduce gear, adjust this high torque speed to the optimal wheel speed. Then simplicity of single speed transmission, fewer components, no clutch, torque converter or complex. Then reduce complexity leads to fewer points of failure. The simplicity reduces complexity, cost and weight. So these are the fewer components. Because of that, these are the simple design. Then compact design, single speed systems are often integrated with electric motor and differential into a single unit. That I will take in the case study. Reduce the overall size. The size is also reduced, and weight of the drivetrain. Reliability, because of fewer moving parts, results in longer lifespan and lower maintenance requirement. Then efficiency of single speed transmission, energy loss reduction, streamline power delivery. This is what very important, and improve the range. Then limitations of single speed transmission, it is high speed efficiency and heavy duty applications. It is not applicable to heavy duty applications. You cannot use for truck or tractor. Okay, and therefore this is not used in case of very high duty, heavy duty application. So these are the examples of single speed transmission. Then multi-speed transmission. Now this multi-speed transmission improve its potential for enhanced performance. Now offers advantages in efficiency and adaptability. Challenges in implementation. It is very difficult to use actually, but the maximum you can use up to 2-stage or 2-speed multi-speed transmission system. Now performance benefits. In performance benefits, improve the efficiency. In improve efficiency, the optimal motor operations. That is, electric motors are most efficient within a specific range. So multi-speed transmission allows the motor to stay within this range. So this is what the enhanced optimal power. Then extended range. The range can be increased by maintaining the optimal efficiency, or multi-speed system can improve the vehicle range, especially at higher speed under the heavy loads. At high speed under heavy load. Heavy load is important because it is only applicable to heavy loads or tractor and buses, truck and buses. Then better acceleration of top speed. In case of this top speed, you can increase the better acceleration at high speed. Then enhanced torque at lower speed. The lower gear ratio in multi-speed gear system amplifies the torque, resulting in quicker acceleration from a standstill. You can stand still or you can immediately accelerate. Quick acceleration is possible. Then improve high speed performance. Okay, improve high speed performance. Then suitability of diverse application. This is also one of the important parameter. Heavy duty vehicles, trucks, buses and other commercial electric vehicle benefits from the multi-speed transmission by adopting various load condition and terrain surface. Then high performance sports electric vehicle. So this multi-speed gearbox is used in multi-speed means two speed for high speed motor speeds vehicle, sports vehicle. So this is the performance benefits: improve efficiency, better acceleration. Now the challenges. The challenges are increased complexity. The complexity is more because it is two-speed gearbox. So of course the challenges are more. Multi-speed gearbox, you require some additional components, additional parts are there, and therefore you required the increased complexity. Complexity is increased, more components, that is multi-speed transmission require additional gears, synchronizers, and shifting mechanism, and so on. Then integration challenges, because when you have to synchronize, we have to integrate on the system. So synchronized gear changes with the high speed rotation, high speed operation of electric motors in technically demanding, and therefore cost and weight will increase because of additional components. And this is also the demanding area for the research. Then cost and weight, when the weight will increase, cost will increase, and so on. So these are the parameters: durability, increased wear, more number of components, high torque handling, you have to handle high torque, and therefore more power is required. Then software and control complexity, because for seamless shifting, okay, from one gear to another gear, you require the clutch, you require the shifting mechanism, and therefore this software control is important. Then applications are this Porsche and Taycan. This is the application. Then direct drive system. In direct drive system, what happened? You can use the engine, or you can use the engine or motor directly to the axle or wheel. Okay, this is what the direct drive. Without gear drive, without any transmission system, directly you can transmit it directly to the wheels. This is what the direct drive system. The motor directly drives the output shaft, eliminate the need for gearbox. You can reduce the gearbox, you can eliminate this clutch and other complex transmission mechanism. Now this is commonly found in electric vehicles with not commonly, but it is rarely found in electric vehicle, but it is commonly found in wind turbines and industrial machinery. The benefits of direct drive system is simplified design, improved efficiency, reduce noise and vibration, because less number of components you are directly connecting, and therefore the noise and vibrations are less, compact and lightweight, low maintenance cost, and enhanced performance. So these are the benefits of direct drive. Then limitations of direct drive system: high cost. Of course, the cost will increase. Advanced material and manufacturing techniques required, because when you have to use materials for that, to, in one directly you have to use the unit. So some advanced material and manufacturing techniques are required, and the cost will decrease. Motor size and weight: to generate the sufficient torque without a gearbox, the motor must be larger, and therefore it requires the more weight. And then thermal management is also important parameter. Without transmission, or overheating is there, and demand, high torque demand is there, and therefore overheating necessitates sophisticated cooling system. Then limited speed range: without a transmission, adopting a varying high speed and torque demands can be challenging, especially at very low speed, very low and very high speeds. So this is what the limited speed range. Then power consumption: efficiency at low speed may drop, and maintaining the performance across a broad range of operating conditions. and therefore power consumption is more specialized control system. Okay, specialized control systems is required because you are directly using to drive system or wheel axle. So these are the advantages, limitations of direct drive system. Now applications in electric vehicle rarely but commonly used in wind turbines, industrial equipment, home appliances, especially in case of washing machine, etc. Now then second or the next innovation one is the dual clutch transmission. In dual clutch transmission, what the two clutches are used, or twin clutch transmission is there, and this is a type of automatic transmission, uses two separate clutch for odd and even gear sets and allows the faster and smoother gear shifts compared to traditional and or manual transmission. Here I have shown the torque flow diagram where the two clutch systems can be used. So it is a type of automatic transmission. So this is also one of the important area where you can work. Then mechanism of dual clutch consists of these two clutches, then independent gear set is required. Then electro-hydraulic actuation. To actuate the gears, you require some electric or hydraulic actuation. And pre-selection of gear is possible. Pre-selection of gears means while one clutch is in engage and transmitting power, the next gear is pre-selected by the other clutch. So that it's possible in case of twin clutch or dual clutch transmission. So this is pre-selection of gears. Then operations of a dual clutch transmission starting from rest. So if you have to start from the rest, when the vehicle starts, the clutch from the first gear engage transmitting power from the engine to the wheels. This is what starting from the rest. Then change gear change as the vehicle accelerate and shift to the next gear. The second clutch engages while the first clutch disengages. So this process is what the simultaneous or very smoothly done, and therefore the advantage is what the seamless or smooth transmission of torque or power. Then downshifting, then automatic or manual mode. So most dual clutch transmission system is allow drivers to choose between fully automatic operation or manual selection. Then advantages, fast and smooth gear shifts because there is no time lag or jerks, and therefore the fast and smooth gear shift is possible in case of dual clutch. Improve fuel efficiency is improved. Better performance and compact design. The disadvantages of dual clutch transmission is the complexity. Complexity is because there are two clutches that you have to handle. Then low speed behavior, maintenance cost is more, and we require more thermal management. Now this is the benefits: faster gear ratio, improved efficiency, high enhanced performance. The performance is also increased. Now these are the applications of electric vehicle model for using DCT. Then continuously variable transmissions. Now understanding of CVT. It is a type of again automatic transmission. This is also one of the important area where you can work, uses flexible belt or chain and adjustable pulleys, because this pulley belt is very important. What is the material of the belt? Steel belt are also used. So life is also important parameter. Therefore you have an area where you can work on this belt. Belt is the weakest part of this continuously variable transmission, where you can work for as a research. Then provide an infinite range. That is what the main advantage of this understanding of CVT. Then continuously adjust its ratio to maintain optimal engine or motor efficiency. Okay, this is optimal performance can be obtained by using this continuously variable transmission. Infinite gear ratio you can obtain. Then gear ratios provides an infinite number of gear ratios within its range allowing the smooth and optimal performance. This is what the advantage. Mechanical design uses belt or chain between the two adjustable conical pulleys, altering their diameters to change the gear ratio. Shifting eliminates the need of shifting gear. Shifting is not required. It is providing a seamless driving experience. Then efficiency continuously adjusts to maintain the most efficient ratio, providing fuel or energy efficiency. Now, these are the advantages of CVTs in electric vehicle: smooth power delivery, improved comfort comparatively because there is no jerk, the seamless acceleration, enhanced efficiency, optimal motor operation, reduce energy loss, low speed precise. Low speed you can obtain very precise control on speed for ideal application like city driving or autonomous vehicle, where you required some very precise motion is required, then you can use this this CVT system or CVT. Because in autonomous, what actually the object detection, so normally this object detection or blind spot detection, so this lane detection, so this in autonomous vehicle, this CVT is used. The future aspects, the material advancement. The material advancement is very, because development of more desirable, durable and efficient material for belts and chain. This is what where the area where you can work. Then integration with electric powertrain. Okay, the integration is means what you have to integrate all the elements or the components. Then high performance applications require precise control, torque and speed. Autonomous vehicle, smooth and efficient operation. Then integrated transmission and drivetrain system. Now this is the concept of, what is the concept of integrated transmission and drivetrain system? It is a combination combining transmissions with other drivetrain components. That means electric motors, inverters and differentials, okay, they are combined into a single compact unit. Now this is single compact unit and therefore it is integrated transmission or and drive system, drivetrain system. So all components are combined in a single unit, okay, and this is what the axle and the wheels, and therefore the total space is less reduced and the weight is also comparatively, but it is a complicated design and for that you required electronics controllers and etc. Simplify the drivetrain architecture. The architecture will increase or simplify, enhance performance and improve efficiency. So this is also one of the important area where you can work, combining transmission with other drivetrain combination, the transmission system, electric motor. What is the integration part or what is the combination? Differential integration, electronics control unit. Okay, these are the different and that you have to combine in a single unit. Now the weight is reduced. The components are fewer components, then compact design, simplified manufacturing, improved energy efficiency. Energy efficiency is improved and therefore reduced loss. Okay, energy loss, optimize operation, thermal management is improved because of less components. Then enhance performance, seamless power delivery, and then faster response time. The response time is very less. Then increase design flexibility. The flexibility is there. Now this is the case study of what the Tesla, where electric motor and permanent magnet synchronized motor is used. The speed of this permanent PMSM is very high. Normally it is more than 25-30,000 RPMs, and therefore it is particularly used for single speed, very rarely used, but it is also used, this motor is also used for two speed, that is multi-speed. Then benefits, compactness, efficiency and thermal management. This is what the Tesla model. Then another is advanced materials and lightweight. Here this is also one of the important area here, since it is integrated transmission system. So your focus is also on the advanced materials in integrated transmission system. So you required use of high strength material, lightweight material. So what are the behavior of the material that you can study? The aluminum composite alloy and advanced alloy that is used for this system. Then aluminum properties, application, benefits. So this is what the related to the material. Then composites materials are also used. Properties, you have to study the properties, ultralight with excellent mechanical strength. Okay. Then superior fatigue resistance. This is what the composite. The application is structural reinforcement. Then enclosures. You can use this material for enclosures, load bearing components. And the benefits is what reduce weight. Only the benefit compromising strength and enables complex shape for better aerodynamic and structural design. These are the advanced alloys, magnesium alloy, then titanium alloy, high strength steel. Okay, these are particular applications are mentioned, load bearing components, gears, shafts. You can use this material, you can see the behavior of the material, and according to that, you can improve the you can increase the properties of the material. Then reduce weight, leading to better efficiency and range. Of course, when the weight is reduced, the range will increase, lower efficiency, energy consumption. Then improve accelerations, thermal management. These are the durability point of view. The fatigue resistance, corrosion resistance, noise, vibration, and harshness is improved. Then reduce weight, leading to better efficiency and range. These are again the different materials. Graphene and enhance the composites potential for ultra lightweight material. Then additive manufacturing is also important. Enable the creation of intricate lightweight components using this titanium and other advanced material. Role of electronic and software. This is also one of the important parameter because in smart system, smart control system, you require the controllers. The electronics controller, different controllers are required. Just I have told that object detection or lane detection. If you have to find a blind spot, so for that controller, different controller sensors are required, and therefore this is also one of the important area where you can work. That it's controllers. You can design a control strategy for the particular component. Then this is adaptive shifting strategies. The customized shifting behavior adapts the based on driving modes. Then load sensing, driver behavior recognition. Then real-time monitoring, continuous monitoring, real-time monitoring of the vehicle or the monitoring engine performance, torque demand that you can continuously operate. Instant correction. According to that, you have to take the necessary correction action. So that for that you require the corrections and controllers are required. According to that, you have to design the strategy. Then enhance driving experience. The driving experience, the smoother shifts, precision control shift, reduce jerks and improve the ride comfort. The ride comfort is improved when if there is no jerks or reduce the jerks, then automatically your ride will improve. Then customizable modes. Drivers can choose driving modes tailored to their preferred preferences on specific situations. Improved responsiveness, faster and more accurate gear changes, enhance acceleration and overall driving dynamics. Increase reliability and longevity. Reduce wear and tear, fault detection, optimize. Now, this is intelligent control for optimal performance, all driven AI driven controllers, then full vehicle integration, enhanced diagnostics. Then elimination of traditional transmissions, just we have seen that direct drive system, that means directly you can install a motor on the wheel. Okay, so eliminating need of traditional. This is also one of the important, just we have discussed. These are the advantages drive system. and efficiency will increase, performance enhancement. So these are the different parameters or the improving parameters. Now here I will take one case study in which the one of my colleague, Dr. Shweta Patil, she is doing her PhD on the topic that is modular development of conventional vehicle. So whatever is the conventional vehicle, that is Maruti Jain, okay, that she has converted into electric vehicle. The topic is the modular development of conventional vehicle into electric vehicle. That was her topic, and on that she has used uh, a single electric vehicle. That means this case, the first case, that is single speed transmission. That single speed transmission, this is used or replace the conventional engine by single speed. Yes. So the parameters are to evaluate the performance of a retrofitted electric vehicle, that is Maruti Jain car. This is a unit or conventional petrol car. Forward wheel drive, it is a forward wheel drive. The engine is on the front wheel with a manual of 5-speed transmission. It is a 5-speed gearbox, and what she has replaced this 5-speed gearbox by a single speed gearbox, then tested the vehicle, and what are the changes or what are the improvement in the vehicle performance that she has concluded. So this is design parameters. The design parameters are the overall length of the car is mentioned already. These are the fixed parameters. Ground clearance, then gross weight, and top speed is 60 kilometers per hour. She has taken 60 kilometers. Normally it is in actual car it is 95 because of some constraints. Okay, normally the vehicle is used for what we can say that in internal or in city intercity vehicle. This Jain car is used for intercity vehicle, and therefore she has taken this 60 kilometer per hour top speed. Then these are the sizes of tires, the aerodynamics, drag coefficient, density of air. So these are the specifications before design. Now system integration required for old gearbox. Now this is what the adapter plate, or when the design, when the we have to connect the motor, okay, motor with gearbox. Finally, gearbox is of course now it is replaced to a single speed gearbox. But when you have to use a motor normally she has taken the specification is of 7.5 kilowatt electric motor. The speed is 3000 rpm, and I think the torque is 52 Newton meter, and it is AC induction motor. Now what happened? The output shaft of the induction motor and input shaft of the gearbox, that we have to connect. So this connection is very, very important. This should be a very precise connection. This connection is what? A precise. And therefore, some constraints are there. By considering all these constraints or design considerations, she has designed the gearbox. Now in design, it is a single speed gearbox. The ratio is 2 point something. I could not give the data because it is in progress still. It is in progress, and therefore it is confidential, and hence, but still the gear reduction is only 2.86. That means total 5-speed gearbox is now reduced to a single speed gearbox. Now this system, this is actual system, that means in Jain conventional Jain petrol Jain system, this is replaced by now this simple structure. That means this is just like a coupler or coupling. The actual view of this adaptive bush and spline, that means this adaptive bush or spline is just used to connect the shaft of motor and the shaft of gearbox. So this is what the simple arrangement. she has developed, she has designed. Now this is system integration. In system integration, what you have to connect this electric motor. This is gearbox, and this is connected by an electric this coupler. So this is actual view. Okay, actual view of this electric motor, and then gearbox. So this is motor mount. Actually, what happened to connect this in coaxial shaft? What she has lifted this electric motor, and therefore the mounts are provided to just make the precise alignment. This was the extra work she has done. Then these are the observations. What are the initial observations? The initial observations was 5-speed transmission system. It was the Jane car and the 5-speed transmission system. The complex transmission system, number of parameters, number of complex material components were there. And then that she has to remove and reduce. Then complex system integration. The integration is also the joining or connection between the system. It's also difficult. More parts, and the total weight of the gearbox was initial gearbox or the conventional gearbox is 32 kg. It is approximately 32. These are the observations she has taken. And now she has, by considering all design parameters and constraints, the resolutions are what she has transforming from multi-speed to a single speed. This was the target. She has converted the multi-speed gearbox into a single speed gearbox. Motor is directly coupled to a gearbox. This is directly coupled to a gearbox, and this connection or the couple is very, very precise. It is very essential. This was the main constraints of the, because it should be perfectly aligned. Then system integration can be replaced by a single coupler. That means initially this coupler system is required in actual IC engine or the 5-speed gearbox. This type of connection is required. But now it is simple. The system integration can be simply, it is single coupler is used. Then single speed transmission adopted by many electric vehicle. Now this is a common, because it is commonly used. Single speed transmission is commonly used. Therefore, she has used the single speed transmission. Now, what are the outcomes? The outcomes of this work is the development of single speed transmission system. She has developed, she has designed the single speed gearbox with helical gears, and of course all the design procedures she has followed. What are the different steps or behavior of the material? Then failures she has considered, the wearing and other beam strength she has determined and designed this single speed gearbox. It is simple system. Weight is drastically reduced. It is almost, I think, 18 or 19 kilo weight is reduced, and therefore the performance is increased. Now, feasibility of this study, that is old gearbox. Now this is old gearbox system constraints. The perfect alignment with motor and gearbox. The perfect alignment is essential. That I have already told. This is motor and gearbox should be perfectly aligned. The second one is what? The center distance. She has not changed. Whatever is the initial center distance, the same center distance is maintained, and that is 175 mm. This was also the constraints while designing the gearbox. Then reuse of differential is essential. So differential is used, and the same differential which was in the initial 5-speed engine, 5-speed conventional engine, the same differential she has used, and it is reused, or it is same differential is used. Then both axle position needs to be maintained as per the vehicle's current architecture, because whatever is the position of the axle, that was fixed, you cannot change it was fixed. Okay, and therefore the same position of axle, the position of the axle or the location of the axle is fixed, and according to that she has used, she has designed, she has maintained the same central distance, and the alignment is also proper, and the same differential is used. Now this is gearbox details. The acceleration is of 22 seconds. The top speed is 60 kilometers per hour. Motor peak speed is 3000 rpm. The speed of the motor is maximum is 3000 rpm. Then pressure angle is 20 degree. Then helix angle 25 degree. Gear ratio, it is 2.866, because whatever is the tractive force required for the vehicles to start the vehicle from the in worst condition, your maximum inclination or inclined vehicle. So that in that case the torque required, according to that she has designed how much gear ratio is required, and she has taken this gear ratio. Now this is the development of steps in actual view, or the design of gearbox. This is complete gearbox, the casing, lower casing. Then this is input shaft, and this is output shaft. This is coupler, because when coupler shaft that is used to connect the shaft motor and gear motor. Therefore, this is now assembly of shaft. This is gear, input shaft, pinion, gear. Then this is what the differential. This differential is mounted on the same output shaft. This is output shaft. This is differential, and then this is coupler. Okay, the flange. It's a flange, simple flange. So by using this flange and the flange of electric motor, okay, you can connect both the shafts. That is output shaft of gearbox and input shaft of electric. This is the sequence or the steps, development of steps, and this is final assembly. Now this is what the major work she has done, and this is the complete design gearbox of 2.86 gear ratio. Now this is old powertrain. You can see it is very complicated and complex, and the traction motor, adapter, splice, and it is complicated. Now this is simple electric motor. Now this is actual new powertrain, electric motor of I think 7.5 kilowatt and 3000 rpm. This is gearbox. Okay, design gearbox. This is coupler. Okay, the shafts of electric motor and gearbox is connected here through a coupling. Now actual orientation of transmission system. Now you see here the actual view of gen with old powertrain. This is a complicated system. How many elements are there? You can see the different elements or complicated, complex structure is there. And the actual view of gen with old powertrain is now replaced by the actual view of gen with new powertrain. This is new powertrain. The system of new powertrain. This is actual photo, and the weight of new gearbox is 21 kg. Okay, this is actual new gearbox. This is new gearbox, the 21 kg. Weight of old gearbox 32 kg. This is total weight of the gearbox was initially 32. Now it is replaced by 21 kg. Now there is a weight of gear shifter mechanism. The weight of gear shifter is 8 kg. That means 32 plus 8, 40 kg is reduced. 40 kg is removed. And the addition is what? The addition is of what? 21 kg. The addition is what? 21 kg. That means this 40 kg is replaced by 21 kg new powertrain. And therefore the total weight reduction by using new transmission system is 19 kg. Okay, and hence because of this reduction, the range is also increased for the same road conditions. She has taken the test, and with gearbox, with old gearbox, initially it was 103 kilometer for a the kilometer range is 103 kilometer. Then by using new gearbox, it is increased to 122 kilometer. Of course, the weight is reduced and so many factors are there. And finally, for the same road condition, he has tested, and the range, okay, the same operating condition, the range is improved by almost 21 kilometer. So this is what the orientation, actual orientation, or the conclusion of this design of single speed gearbox. I think we should stop here. So if any doubt, any, hello, you can
Yes, sir.
ask.
Participants, if you have any doubt, you can ask. Hello.
Hello.
Sir, there is one question in the chat box.
Ah,
Is the work on Zen completed? If
ah.
yes, what is the range it provides?
Now the range is 122 kilometer. It is improved. It is improved by 21 km. Initially with work with old gearbox. With old gearbox, the range was 103. Okay, that means by using 5-speed gearbox, the distance traveled by the chain is 103, and for the same, it is now 122 kilometer for the same operating road conditions that we have checked.
Dr. Ashish Jaiswal is asking about the total cost for the conversion.
The total cost, it is actually a zero sponsored, and therefore that cost is approximately 50,000, 60,000, I think 60,000 plus almost. The motor is different. Motor is different. The gearbox only the gearbox. Only the gearbox. Huh? The motor is different. Motor is of almost again 25,000 something extra. But the cost of gearbox is this.
Okay, participants, anyone, any question?
Hello, sir.
Yes.
Sir, go
Sir,
ahead.
there is a question. Sir, there is a question. Who allowed to do
Hello.
this? Who allowed to do this to convert the IC engine into the EV? Is any government or authority allowed to do conversion?
Actually, what happened? This is a research project. Actually, this is research work, and in this, we have taken the certificate from ARAI standards. According to ARAI standard, even though we have reduced the weight of gearbox by 19 kg, okay, but there is a weight of what? Weight of battery pack. Because of the weight
Yes.
of battery pack you have to install, na. So because of this battery
Yes.
pack, what happened? The weight is slightly increased. Whatever is the weight increase, that increase in weight is 7% more actually. The total
Yes.
weight initially with 5-speed gearbox, whatever is the weight, that weight is increased by battery pack by 7%. By 7%. And
Yes.
but ARI has given it is permissible value is 17%, and therefore it is certified by ARI that whatever is the permissible value, that means up to 17% you can increase, you can give increase up to 17%.
Okay. Thanks.
So it is certified by ARI.
Yeah. Right.
But
Hello.
you cannot allow on the road. It is not permissible.
Yes. Yes.
Just for the research work they are
For the
giving.
research work.
Yes, 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 yes.
Yeah. Hello. Good evening, sir.
Yeah.
Yeah, this is Dr. Ibrahim, sir, from Mumbai. Sir, I wanted to know what are the different AI-driven controls used in the transmission system?
In transmission system, still it is in progress. AI driven means what? How to control the speed according to smart transmission system. So it's in progress.
Okay.
Uh,
Okay. Yet not fully developed.
Yet not fully developed. In only in what we can say the autonomous vehicle. Some what we can say that.
मोबाईल पाहिजे का हॉटस्पॉट पाहिजे
Hello.
Yeah, sir. I'm listening. You.
रोज किती
Only the control units, electronic control units that is applicable, and therefore object detection or blind spot or lane detection sometimes that you can use as a in
So
case
during
of
your
AI.
presentation, you also talk about some customizable modes. What those
Yes.
customizable modes basically?
That customizable modes in terms of what integration of the vehicle, integration of the transmission system.
Okay.
That means some standardized components you can use, or that we can say that is a modular design.
Right, right, sir. Thank you so much, sir. Thank you so much.
Yes, sir.
Yeah.
Hello, sir.
Uh,
Myself, Dr. Manish. Sir, as you said, there is mostly electrical vehicle are using single gear. So
Single-
it is only for the road condition or off-road condition also. Off-road vehicle can.
It is for passenger vehicle.
It is a for
Passenger vehicle. That means
okay.
on-road vehicle.
Not on-road vehicle only.
But
No,
for
because
heavy.
okay.
But you can use in case even in for off-road vehicle by using a single speed gearbox. Okay? By using single, but with a high motor specification.
Okay, so it will also be depending on the two-wheel drive or four-wheel drive.
Yes, two-wheel drive it is used or four-wheel drive. Directly in case of the four-wheel drive, it is I think in some cases it is direct drive.
Okay. There is no required gear. That is directly
Yes, sir.
controlled by the motor.
Yes.
Okay. Okay. Thank you, sir. Sir, please share the slide with us, sir, because the study slide has been showed to us, sir.
Okay.
Sir, good evening, sir.
Yes, sir.
Okay,
Sir,
we'll take one more
slide
question.
number 44, sir. Slide number 44. And you were talking about this design parameters coming to these existing car parameters or new parameters, sir?
Existing parameter. Yeah, existing. Yes, that means the old car, the same car is same. Only the gearbox is changed.
Okay. Sir, and
Parameters
you were
are-
talking about the
all these
converter, sir.
parameters. All these parameters are same.
Yeah, old same parameters only.
Same parameters. The same car we have used. Same car we have used.
Okay.
But only the different gearbox. The gearbox is single speed gearbox. Instead of 5-speed gearbox, now it is single speed gearbox.
Sir, and regarding converter, sir, then last slide, maybe last slide, you're talking about the existing and also last slide. I think last one. Here, sir. So here, what are the which type of converter you're using, sir? Converter.
Yes. This is converter is the essential part, actually. Which type exactly I don't know. So, madam, please can you tell me the exact converter specification?
Hello, am I audible, sir?
Yes, madam.
This is a buck converter. Actually, the battery voltage is 72 volt, and that battery is a primary battery, and secondary battery is required for the auxiliary purpose. So that voltage is 12 volt. So that's why it is a buck converter is used for this case, particularly for this case, which will decrease the voltage from 72 volt to 12 volt.
So either existing one, you're talking about either existing one or proposed one, madam?
Yeah.
Actual one.
Hello.
But you're talking about this converter is related to either old.
Sir, converter is this is the buck converter, not a boost. Buck converter.
Yeah, that only, madam. The buck converter, either existing one you're talking about or you're new.
No, it is new. These all parts are new. Controller, converter, motor, battery, these are new. What is the old? Only 12-volt battery is old in this particular case. Then safety knot, relay box, vacuum pump, everything is new. We have installed that.
What about the control part, madam? Control part and also converter, which type of control you're using?
Yeah, controller, that is nothing. Hello?
Yes, madam, please.
Sorry, I think the voice is breaking. Yes, what, sir?
Madam, he is asking about controller.
Okay, controller, that is a motor controller which has to control the motor. As per the vehicle's requirement, controller send the signal to the motor and then it will use the power to the vehicle wheel. So that is the purpose of controller.
No, I'm asking about which type of control you're using, madam. I know the control purpose. Which type of controller you use?
This is a Curtis controller. Controller plus inverter. That both are the same dual mode controller.
What about the gate signal, madam? You're using the either buck converter or control signal. What are the gate signals?
Sir, actually, this is actually my research case, so I cannot disclose some things here right now.
No, I'm asking about the gate signal, madam. How you design this one gate signal? Like your buck converter, you're going to use the gate signal, na?
No, gear signal is not. Actually, in this particular case, what happens? The controller, one end of the controller is connected to the accelerator pedal. When the driver presses the accelerator, so that signal will receive the controller will receive that signal and it provides that information to the motor. And as per that signal, so it vehicle will work. That is the case.
No, my question is, so you're using converter like buck converter, boost converter, buck boost converter. So you're going to give the gate signal. Which type of gate signal you're going to use? Either PWM signal or any other signal?
No, sir. No.
Then what about gate signal, madam, in that case?
Actually, Kai sir. Due to some confidential case, I cannot disclose these things, sir.
Okay.
That is one of the.
Okay, madam, no problem. This is confidential means known. Actually,
madam, can I interfere? Hello.
Yes, yes, Suryavanshi sir. Please go.
Myself is Suryavanshi sir. Madam, what he want to know is that in controller, buck controller, we use the.
No, sir, buck is not controller. Buck
converter.
Buck converter. Buck converter. So in buck converter, we use either the power MOSFET or IGBT, that's the power device, and to on of that power device,
yes,
we have to give some gate signals.
Exactly.
So he wanted to know what kind of the gate signal, because there are various ways to provide the gate signal to such a power devices, PWM and so on and so forth. So that is what his question.
Actually, I understand that question, but due to some constraint, I cannot disclose something regarding this.
Okay,
this is
thank you.
related work, na.
Okay, madam, thank you, no problem.
So that's why, sorry to say, but I cannot disclose these things. Sir.
It is fully sponsored by a company. And
okay, sir, thank you, no problem.
I think we are running out of time, so we'll stop here. Is it okay, Kale sir? Because our next speaker is also there.
Yes.
And I hope.
Thank you very much. Yes.
So thank you for the wonderful session. Thank you, sir, for taking us through the innovations in EV transmission systems. The examples, insights, and topic suggestions shared by you will surely equip everyone to tackle the challenges in EV transmission system. On behalf of organizing team and all the participants, I extend heartfelt gratitude to Dr. P.R. Kale sir for taking time and share valuable knowledge and experience with us. Thank you very much, sir.
Okay, thank you.
Few instructions from the organizing team. It is observed that few participants are still without